Late last year, I was browsing Twitter and I found a post from a lady called Gina. She is the open source developer behind the project Octoprint, an open source 3D printing web interface. We got talking and I thought actually her story was pretty interesting. And so what follows in today's video is an interview with Gina talking about how she uses Tailscale as part of the open source build process for Octoprint, connecting the Raspberry Pis on her desk with GitHub Actions in the cloud and just bringing them all together. So join me in this new series on the channel where we interview developers from various projects across the internet with Gina from Octoprint. I'm delighted to welcome Gina from Octoprint to the channel. A few months ago, we got talking about how Octoprint has a very unique challenge around building infrastructure and testing software between GitHub Actions and Raspberry Pis running on Gina's desk. So that's what we're going to talk about today, is how we can connect different remote infrastructure building tools together using Tailscale under the hood. So welcome, Gina.
Hi there.
So what got you first into building Octoprint? Actually, I should probably wind back. For those people that don't know what Octoprint is in the first place, let's do the elevator pitch of what is Octoprint.
Yeah, so Octoprint is the snappy web interface for your 3D printer. And it so happened that in November 2012, so over 10 years ago, 11 years ago now, actually, I got myself my first ever 3D printer. And back then, when those things were, yeah, even less plug and play than they are today, you had to basically tee that into your computer all the time, keep an eye on them. Like personally, you had this thing sitting in my case, in your office, um, basically taking up your PC all the time while it got fed the data that it needed to print. Then the print took hours to days on end. It produced fumes, it produced noise all the time. And all in all, it was just quite annoying to have it tie up a PC all the whole time, sit in your office all the time and such, and you not being able to use the room anymore for anything else, or the PC for anything else anymore. And so I so happened to had a vacation coming up then over Christmas. The Raspberry Pi had just come out in that year, and so what I did was I sat down and yeah, basically created myself a little web interface that would allow me to monitor the 3D printer through a web camera connected to a Raspberry Pi, the Raspberry Pi directly hooked up to the printer, feeding it data, getting a full like feedback loop going there, knowing when the job would be done, seeing if there were any errors and all that, and basically just allowing me to put that thing in my spare bathroom instead of it tying up my uh, office here.
That's the way to do it. I
Yeah,
I
and
can't
so
actually imagine a 3D printer without a remote control these days. I mean, if you look at some
yeah.
of the new ones, they come with all this stuff baked in, but it's important to note that I guess if you're talking about Raspberry Pi 1, that was 2012-ish era, I
2012. It
guess.
had just come out in that very year when I decided to try that with that thing.
Yeah, that's going back in
And
time, and these things were not, they were not internet connected back then.
they usually didn't even have an SD card slot. So usually these days, unless you have one of the newfangled ones that directly have a network connection built in, you take a USB stick or you take an SD card and put that into the printer, and the printer will read what is on there and print that on its own. You will still have to keep an eye on things, of course, but it at least will no longer tie up a PC necessarily. Back then, the add-on alone that would have allowed me to do that for my printer back then would have set me back $100. And so I figured 35 for a Raspberry Pi is, less expensive, and it gives me so much more.
Back when the Raspberry Pis were actually cheap and affordable. Remember those days?
Yeah, yeah, back then when. I should add that Octoprint does not only run on a Raspberry Pi, it runs basically everywhere where Python runs. So you don't have to use a Raspberry Pi. You can use an Orange Pi, or you can use an old laptop or whatever.
It's an important distinction because I think over the years it's kind of got diluted by the OctoPi project. I think certainly that's how I came across it in the first place.
Yeah,
So Octoprint is what? It's a collection of Python scripts.
it's basically one giant Python script, I would say. Like it's a web
Okay.
server written in Python, and the front end, yeah, using the web technology from 11 years ago. Um, and a plugin interface that also allows you to extend it in various directions. I think we currently have something like 350 plus plugins on the official plugin repository. And the plugin repository is also why we still have a web technology connection stack from 10 years ago, because of course, plugins also bring along some front end parts, and just swapping something out there means you render all of the old plugins obsolete. So there is a path of migration here that needs to be walked, but that is still ongoing. So
You've got the Windows or the x86 problem going on right there. You want to maintain the legacy, but at the same time, moving things forward. In a decade, web standards have moved on a little bit.
yeah,
But I
and
would argue that the plugin architectures is what's made Octoprint have that longevity in the first place. Without being able
probably.
to extend it like that, it wouldn't. If I think about it, I want to, for example, have the lights around my printer change color via MQTT in Home Assistant, and I can do all of these things thanks to different plugins that you haven't had to write.
Yeah, the part with you haven't had to write was actually one of the most important things, or the reasons why I created this whole plugin architecture. Because so I started working on that, I think, in 2014 or 2015. So that's also uh, quite a while now. And back then, when I was the only maintainer, I still am the only maintainer, but I had a whole ton of people who were asking for the one or other very specific feature, very specific to their workflow or their hardware and such. And I found myself more and more in the situation that while I could see why something was a good idea to have for certain people or with certain hardware, I simply was not able to test it in any way, and
Right. Yeah.
such not really able to maintain it. And so I figured I should give people a way to do that themselves. And yeah, I mean, plugins are just the prime solution for something like that.
It is interesting when I listen to a lot of development podcasts and stuff, particularly in the Apple ecosystem. You hear people, clamoring to buy. This week it's been the Vision Pro, has been everywhere. I think they need to buy these things to build their apps, to test them, and all this kind of stuff. Which hardware testing can be really difficult, and this leads us nicely into the meat of the conversation, I think. So you build your software using GitHub Actions, right, which is a cloud-hosted build environment.
I wouldn't say that I necessarily build my software with that, but I certainly use it a lot to test things. I have a full-fledged test suite that also involves end-to-end tests. Um, Unit tests, a whole bunch of stuff. It also packages things up, makes on releases, takes things, loads them up to PyPI and such. Um, but all in all, yeah. So I basically have this huge build workflow that runs on GitHub Actions that takes care of a whole bunch of things of basically checking that everything is all right, that syntax is okay, linting and all of that, and then finally pushes it out if it is a release, and otherwise just says yes or no. But yeah, that is only Octoprint. Prior to releases, I have the challenge that I have to basically run through the whole update scenario of getting a base state of an earlier version on a specific Python environment, on a specific system environment, and see if the update runs through flawlessly. Because in the past, I made the experience that with certain stuff out in the field, updates would fail, even though they would work just fine here. And I obviously want to avoid that from happening. So I had to find some way to do that. And this is where where basically I built myself a little test rig that consists of 3 Raspberry Pi 3s, three, how could I say that? How should I call that? I forgot how they are actually called, but basically 3 little devices that pretend that they are an SD card, unless via a USB SCSI command you tell them, no, you are now please going to be a USB storage, and then you can flash that thing, switch it back over into being an SD card, and that is what I use to remotely flash these 3 Raspberry Pis in my test rig. And thus am able to go through various test scenarios without having to constantly swap SD cards back and forth, which is something that I did up until maybe 2021, and which was driving me absolutely insane on every single release cycle and release candidate cycle. Like imagine going through something like 8 to 10 test scenarios, and for everyone you need to flash an SD card. So you need to power down the Pi manually. You need to unplug the SD card manually. You need to plug it into a card reader. You need to start up an imager. You need to wait until this imager finishes. Then you have to do all of this in reverse and power the Pi back up, wait until it's there. Now I just have a Python script that does all of this for me.
And that Python script runs in GitHub, right? And then
That actually, so during the regular testing, that still runs locally. But I also have this. So I do manual steps here. But once I have my local tests all green for an update scenario, what needs to be done is also a new image build needs to happen. So you mentioned Octopi. That is currently the most common way to install Octoprint, even though, as I mentioned, not the only one, but this is basically a pre-built Raspberry Pi image that has Octopi on board, a webcam streamer on board, reverse proxy pre-configured and all of that, so that you can just flash that and use the Raspberry Pi images configuration screen thingy to configure your Wi-Fi, and then you're done, basically. And the thing is, for a long while, we did an Octopi release, and then was that was that then. So that image never again was updated. People were flashing Octoprint versions from half a year to a year or maybe more ago, depending on when they pulled the image, and then had to update, and sometimes that would go wrong or something, and basically they were installing stuff anew and it was outdated already. So that was annoying. And that was something that, of course, was also not that great from a security perspective and such, because would people actually update and so at some point I created an update script that would take an Octopi image and basically virtually boot it, not really boot it, but like use a change root and go into it in a QEMU environment that would simulate the architecture of the Raspberry Pi. Would update Octoprint on it, would also update some system images on it, system packages on it, and do some other fixes if needed, and be done with it. But of course, whenever I wanted to release one of these images anew, I would have to go through a whole gauntlet of testing again. And so I now had this issue. I had a full-featured end-to-end test suite on one hand that ran on every single release on Octoprint. And I had this GitHub action-based image build that would update an Octopi image with the latest Octoprint version, and basically dump myself an image on GitHub Actions, but that was untested, which I then had to manually load down, update, flash to one of the machines on the test rig, manually click around, look if everything was all right. And at some point, I just figured that there must be some way to automate that. But of course, there was the problem that this image, triggered by every single release, was created on GitHub Actions. So it was in the internet. And the test rig is sitting like half a meter away from me right now on my desk. I didn't want to put the test rig into the internet, and I couldn't bring GitHub Actions here on my desk. So I needed to find a way to have the two of each other talk to each other without me having to open up holes in my firewall or anything like that. And this is where I stumbled across Tailscale. So what I'm doing now, and quite successfully though, is imagine I prepare a new Octoprint release. The whole build suite runs through. The unit tests are okay. The end-to-end tests are okay. The linter says everything is fine. All my update tests before that were also fine. So a new release is tagged, uploaded to PyPI. Everyone is happy. What now happens is this build will also now ping the image build. the image build will now pull in the latest Octoprint version, create a new image based on that, update everything else that needs updating and fixing everything that needs fixing and all that. And in the end, an image file falls out. And that now will trigger another workflow that pulls in this image. So first of all, that opens a Tailscale connection to an internal Tailscale network, in which I call it the flash host. So basically, the controller machine of the test rig is one node, and the GitHub runner is now another node. And the GitHub runner will know the flash host. Hey, by the way, please pull an image from this URL, flash it to this machine. That is the first step. And once this flashing is run through, the runner will know, okay, that worked great. So the next step comes. It pulls down the Octoprint sources and runs the whole end-to-end test suite against the image. So when that is green, I know apparently nothing terribly broke here. It's still booting. It's still getting Wi-Fi. It's still Octoprint is still coming up. I can even fetch a snapshot from the webcam, for example. I also check if the error log has any errors. The Octoprint log has any errors in it. I check if the JavaScript console has any errors in it, and so I go the full 90 yards basically, from a software release to a ready flash device on my desk, and all of that completely automated through GitHub Actions. Like after the release, something like 2 hours later or so, I get a ping in my notifications from GitHub, like there is a release waiting for you to say, yes, push this out. I don't necessarily need this additional step. I just feel better having it in there. And so once I confirm that, the image goes live and can be flashed by anyone worldwide.
That's fantastic. That's a very, dare I say, complicated workflow you've had to sort of refine over the years there. I mean,
Yeah.
before Tailscale came along, I suppose it wouldn't have been terribly easy for you to link the two together. You might have had to build a manual WireGuard tunnel or do some weirdness with port forwarding in your firewall, that kind of stuff. And
Yeah,
now,
I
like,
yeah.
what happens is the GitHub runners basically got full access, in terms of networking, to
Limited
resources
access.
elsewhere on your tailnet, wherever they are, right?
Limited access. I have a very strong ACL because
Oh, good, good. I'm glad to
yeah,
hear that.
yeah. Like the only thing that this runner is allowed to access is basically a web host endpoint on the flash host, which then triggers some local stuff to happen. But yeah, this is the whole idea. My goal was to find somewhere where I still would feel safe in my own local network here, where I would not have to worry about anything getting compromised by, I don't know, someone breaking into GitHub runners, someone breaking into Tailscale. So that was basically the idea here, being very, very safe and secure, but still allowing me to put these two parts on completely different parts of the world together virtually, so that I could automate the final thing that was stopping me from having the whole process be completely independent of me flashing things, carrying SD cards around, or clicking on buttons beyond yes, launch this release.
You are going to have to give me a link to that SD card emulator switcher device that you talked about. That sounds like one of the coolest things
I
in the
think it
world.
was called SD-Mux. They are quite expensive. They are done by a little company, yeah, not that little, but like mid-sized a company here in Germany. And I have a blog post written up about how I created the whole test rig that does not yet have the whole integration with GitHub Action Runners in it, but it at least has the part where it saved me 2 hours or more on every single release and release candidate.
Amazing.
So
Yeah.
yeah,
So you say it's expensive, but your time isn't free either.
that was the thought. I started with 2 Raspberry Pis, and that was already rather great. And then when I added this integration with automatically flashing the image, I added a third one so that I could always know that at least one would be free. But I still have not in there is something like scheduling, so that the flash host would automatically know when a request to flash a new image comes in on which one to put that. So that is still always the third one, but so far it hasn't had the need to be utterly fancy, so things are
The
fine
fact you
still.
call it a flesh host just has me giggling every time.
I didn't know how else to call it.
Meat space box. I don't know. Yeah, Flesh Host is pretty
No,
good.
no, it's a Flash host. Yeah. So I
Yeah.
can shoot you the link to the blog post. It also has an image of the test rig and yeah,
Yeah. Please
with a
do.
fancy laser cut frame and all of that. So
So fancy. Speaking of links and things like that, there'll be a plethora of links down in the description down below. A link to a talk Gina gave at Nova 2022, detailing a lot more of the specifics behind this, along with some of the Octoprint project links and the blog and where you can find Gina as well on the internet. So thank you very much for joining us today. It was an absolute pleasure, and I'm delighted to nerd out with somebody who's just,
yeah,
found a real world problem and solved it using Tailscale.
I also have to say that I giggle uncontrollably every single time that I push out a release these days because of the whole. I mean, just like I celebrate how well the test rig works, and when I then get this little release is ready notification from the GitHub runner, it's always like, yes, I'm still writing the release notes or the announcements and cross posting them everywhere, and I can hear the fan on the flash host spinning up because it just got the command to flash
Amazing.
the third pi and stuff, and it's like everything is just working automatically. Automation is great when it works. When it doesn't, it's horrible. But when it works, it's amazing. Also, I have Home Assistant running here myself, and for the longest time, I've had the components lying around here to build myself like a little button box to really physically press the launch this button.
Ooh, and
But
you're going to need
I,
like a missile control switch over the top of that, so
yeah,
you can't
something like that.
accidentally. Yeah,
I still
that
haven't
sounds like
done
fun.
it, but that's like also an idea that I still have to just really have this physical component to creating a software release of something, of pushing a button and then it goes out.
So yeah, I just wanted to say thank you very much for joining us, and we'll also probably connect again in the future on the self-hosted podcast to talk about some other things besides Tailscale. But on this channel, of course, that's what we talk about most of the time. So until next time, I've been Alex from Tailscale.